Hello. In our previous lesson, we covered the theoretical aspects of the while loop and developed an understanding of its basic usage and working logic. In this lesson, we will reinforce the topic by revisiting and implementing the sample project we introduced at the beginning of the previous lesson. We will complete our training using the Tinkercad simulation platform, which provides a virtual environment for testing Arduino circuits. We will also be doing the application physically, but make sure to watch the video all the way to the end before setting up the circuit yourself, because there's an important point we'll explain later in the video that you need to pay attention to. We began by adding an Arduino Uno board to our circuit in the simulation workspace. Next, we place a potentiometer in our workspace, which we will use to control input values. We connect the left leg of the potentiometer to a 5 volts power source to provide a steady voltage. To make the wiring more intuitive, we can change the cable colors. Since this is a voltage line, we set its color to red. We connect one leg of the potentiometer to the ground pin to complete the circuit. As a convention, we set the color of the ground cable to black for clarity. We will read values from the middle pin of the potentiometer by connecting it to analog input pin on the Arduino board. This setup allows us to control the motors based on the analog value we receive from the potentiometer. Now, we need to add motors to our workspace. By typing the word motor in the component search bar, we can view and select from the available motor types. We will be using 2 DC motors for this project. So, we drag and place DC motors into the simulation environment. We proceed to establish the ground and other necessary connections for both motors. We connect the ground wire from the Arduino's ground pin to the first DC motor. From the same ground pin, we extend the ground connection to the second motor on the left. In this way, we duplicate the ground line so that both motors share the same ground reference. You could do this differently as well. We can also organize the wires by changing their colors for readability and then continue building our circuit. We will control the motors using the digital input-output pins on the Arduino. The motor on the right will be controlled via digital pin number 2. We connect this motor's input wire and assign it a blue color to distinguish it visually. We will use digital pin 3 to control the second motor. We connect this to the positive terminal of the second motor. To easily identify the wires, we can assign the second motor's cable a brown color. At this point, we have successfully completed the setup of our circuit. The main purpose of this circuit is to control the motors based on the value obtained from the potentiometer using a while loop in our code. Now, we are moving on to the coding part where we will write the necessary commands. First, we define some constant variables using the const keyword. We do this because the pins to which the motors are connected pins will not change throughout the program. We write const integer motor1 equals 2 to define a constant variable for the first motor. As we noted earlier, motor 1 is connected to digital pin number 2. Similarly, we assign the value 3 to the variable motor 2 as it is connected to pin 3. With this, we have completed the declaration of our motor-related variables. Now, we move on to the setup block. Inside the setup function, we use the pinMode command to specify how each pin will be used, in this case, as outputs. We inform the Arduino board that pin 2, which is assigned to motor 1, will be used as an output by writing pinMode motor1 output. We can copy this line of code and paste it below to define the second pin. Remember, the motor 2 variable represents pin number 3. So, we write pinMode motor2 output to tell the Arduino that this pin should also function as an output. Now we move into the loop block, which continuously runs as long as the Arduino is powered on. Here, we begin by writing while, followed by the condition that will control the loop. We use the analogRead function with a 0 in parentheses, indicating we are reading from analog pin. If the value read from analog pin is less than or equal to 500, as we've seen in our circuit, the analog pin receives its input from the potentiometer, which allows us to control the voltage. So if this value is 500 or less, we write digital write motor 1 high to turn on the motor connected to pin 2. In other words, we provide power to pin 2, which was defined earlier as motor 1, thus activating the motor. This will cause motor 1 to run, and after that, will ensure that motor 2 is stopped. We copy the same command structure and paste it to the next line. This time, we write digital write motor to low to turn off the second motor when the condition is met. Now, we design the second while loop. We simply copy the previous while loop structure and paste it below. This time, we write while analogRead as 0 is greater than 500. Under this condition, we want the second motor to operate, and we want motor 1 to stop running. In summary, only one of the two while loops in the loop block will be active at any given moment, and it will continue running as long as its condition remains true. So, if the analog value is 500 or less, the first while loop's commands will continuously execute. If the value is above 500, the second while loop will become active and its commands will run continuously. Now, let's run the project and analyze the results of the code and hardware setup. The flame symbol has appeared, which indicates that there is a problem in the circuit. Despite this, the simulation appears to work. However, we should never run the physical circuit this way. When DC motors operate, especially at startup, they tend to draw a high amount of current. However, Arduino's digital pins can supply only about 20 to 40 milliamps of current. In contrast, even a small DC motor typically requires 100 to 300 milliamps, which can cause the Arduino's output pins to burn out and lead to the Arduino stopping completely or becoming permanently damaged. Additionally, as DC motors spin, they act somewhat like small generators. When a motor is suddenly stopped or its direction is reversed, a reverse voltage known as back electromotive force is generated by the coils. If a protective diode is not used in the circuit, this reverse voltage can reach the Arduino and damage its microcontroller or power circuitry. Of course, there are solutions to overcome this problem. However, before that, let's remove the motors from the circuit without changing the code and replace them with LEDs. This circuit operates with the same logic. If the value read from the potentiometer is 500 or below, the LED on the right will turn on. If it's above 500, the LED on the left will turn on. The code remains exactly the same as in the previous example. You can think of the variables motor 1 and motor 2 in the code as LED 1 and LED 2. The names themselves don't matter, these are just symbolic labels that hold numerical values in memory. Now, let's start the simulation with this setup. At the moment, the potentiometer is producing a value that is higher than 500. This is because a 5-volt voltage is being supplied to the potentiometer's input leg, and this 5-volt input allows the potentiometer to generate values between 0 and 1023. Right now, the potentiometer is fully turned clockwise, which means the analog input will read a value close to the maximum, 1023. Now we rotate the potentiometer knob to increase the resistance, thereby decreasing the analog output value to below 500. In this new state, the LED on the right, which is connected to pin 2, will turn on, while the LED on the left will remain off. So, whenever the potentiometer's value is above 500, the left LED turns on continuously, and whenever the value is below or equal to 500, the right LED is activated through the while loop mechanism. You can physically set up this circuit and try it out in the Arduino IDE application. Now, let's go back to working with DC motors and explore how we can control them using these codes. In this circuit, we are using an Arduino Uno, 2 DC motors, a potentiometer, as well as 2 NPN-type transistors, 2 diodes, and 2 resistors of approximately 220 ohms. For the physical setup, we use BC5 for 7 transistors, which are among the most commonly available NPN-type transistors on the market. As for the diodes, we used 1N4007 and the resistors were 220 ohms. However, using resistors up to 1000 ohms would also be suitable for this circuit. The analog data coming from the potentiometer is read through the Arduino's as 0 pin. This value is used to determine which of the 2 motors will run. Since we cannot drive the motors directly using Arduino's digital pins, we use transistors as switches to supply power to the motors. The diodes placed next to each motor serve as protection against reverse voltages that may occur due to the motor's inductive nature. Before building the physical circuit, let's first test it using a simulation environment. In the initial state, the value read from the potentiometer is close to its maximum. Since this value is above 500, motor 2 will be activated. As we turn the potentiometer counterclockwise, the analog value decreases. Once it drops below 500, motor 1 will start running and motor 2 will stop. As can be understood from the code, if the analog value read is 501 or higher, motor 2 will run. Even if the analog value is exactly 500, motor 1 will be activated. Naturally, motor 1 will continue to run for any values lower than 500 as well. As we discussed in our previous lesson, we chose to use the while loop here because the number of loop iterations is not known in advance. This is due to the fact that the user can change the potentiometer value at any time, making the condition dynamic and unpredictable. In this kind of scenario, using a for loop would not be appropriate. Instead, the while loop is the more logical and effective choice for responding to real-time analog input. So in this application, the movement of the potentiometer directly controls the operation of the motors. At any given moment, one of the two while loops will always be active. There is no scenario in which neither of the while loops would execute. Since the value obtained from the potentiometer will either be below or above 500, there is no situation in which neither condition is met. And in the specific case where the value is exactly 500, motor 1 will still run because in the condition defined in the first while loop, we stated that the value should be less than or equal to 500. Lastly, let's test the circuit with the physical components. Before uploading our code to the Arduino, there is an important point we need to pay attention to. If our circuit includes components that draw high current, such as motors, it is a good idea to temporarily disconnect them. This is because motors can draw sudden bursts of current during code upload, which may potentially damage the Arduino or the USB port of the computer. Therefore, it is safer to disconnect the power line connected to the motors during the upload process and reconnect it after the code has been successfully uploaded. After uploading the code to the Arduino, we should disconnect the board from the computer and power it using an external power source. For this project, a 9 volts adapter or a 9 volts battery would be suitable. You can plug the power supply into the Arduino's barrel jack input. This allows external components, especially motors, to operate more reliably and with sufficient power. However, since a 9 volt battery may drain quickly, using an adapter is recommended for more stable operation. The Arduino continuously reads the analog value from the potentiometer. If this value is less than or equal to 500, motor 1 runs while motor 2 stops. If the value is greater than 500, motor 2 runs and motor 1 stops. In other words, by turning the potentiometer, we can switch between the two motors. This circuit provides a great practical example for both reading analog data and controlling digital outputs. At the same time, it demonstrates the importance of using transistors and diodes for protection. In the next session, we will look at how to use a while loop together with a button in a beginner-friendly example. Thank you for joining this lesson. I hope you found it helpful and that it sparked your curiosity about how we can control hardware like motors using Arduino programming.